Good morning, everyone. My name is Shriya, and today's our topic is three address code. Three address code is generated by intermediate code generator, and intermediate code generator is the fourth phase of the compiler. And three address code is an intermediate code. It is used by the optimizing compilers. In three address code, the given expression is broken down into several separate instructions. These instructions can easily evaluated by the uh, com- compiler and generate and translate it into assembly level language. In three address code, at most three addresses are used to represent any statement. Each three address code instruction has at most three operands. It is a combination of assignment and a binary operator. An example for the three address code expression. Here is the given expression, and in the given expression, a b c are operands, where op is the operator. It is and let's look into the another example in which the expression is a is equals to b plus c, and here the a b c are operands, and plus and assignment operator are operators. How to generate three address code? Let's consider one example. A is equals to b plus c plus d. In this given expression, operators are plus and assignment. Here plus is the operator with highest precedency. So according to the rules, we have to, in three address code generation, we have to give highest priority to the operator that have the highest precedency. So here plus operator is a left associative. So we, according to the rules, we have to firstly evaluate, we have first solve the b plus c and then d. At last we store the result into a. And three address code for the given example, firstly we store b plus c value in t1, and then t1 plus d in t2, and finally we assign t2 value to a. Finally we are storing the result in a. So this is one more diagram that represents the three address code. And let's dig into the implementation of three address code. Three address code can be implemented as a record with the address fields. There are three types of representations used for three address code. General representation of three address code, where consider this example, and where abc are represents the operands like names, constants, or compiler generated temporaries, and op is the operator. Converting the expression a star minus b plus c into three address code. uh, before knowing about the different types of implementing three address code, let's solve this. Let's convert this statement into three address code. So firstly we are storing b plus c value in t1, as the uh, operators or operands in brackets will be having the highest precedency. Then minus and plus or star. So now we will be storing u minus of t1 into t2, and finally the result into t3, where a star t2 is the result. And coming to the implementation of three address code, there are three different representations of three address code. They are quadruple, triples, indirect triples. Firstly, quadruples. In a structure which consists of four fields, namely operator, argument 1, argument 2, and result. OP denotes the operator, and argument 1 argument denotes the operands, that and result or the result is used to store the result of the expression. Advantages of this quadruple are easy to rearrange the code for global optimization, and one can quickly access value of temporary variables using a symbol table. Disadvantages of this quadruple is contain lot of temporaries, and temporary variables uh, ser- temporary variables creation increases as time complexity and space complexity increases. And let's dig into an example of this quadruple and consider the expression a is equals to b star minus c plus b star minus c. The three address code of this expression is t1 is equals to u minus of c. Firstly, we are solving the left part of the plus. So here plus will be having the highest precedency. So firstly, we'll be uh, like plus will dividing the expression into two different parts. B star minus c of left side of the plus is one part, and another side and right side is the another part. Here we are evaluating the left side part of the plus, because here star will be having the highest precedency. So t1 in t1 we are storing u minus of c, and in t2 we are storing b star t1, and then now we are storing u minus of c into t3, which is in the right side of that plus operator, and we are storing b star t3 into the another temporary variable, and finally t5 is another temporary variable in which t1 plus t4 is stored. Finally, the result is assigned to the variable a. So this is the quadruple representation of the given expression. Here we'll be having as mentioned 5 columns with the 4 elements. One is the operator, and arg1 is the argument 1, arg2 is the argument 2, and finally result. Here we'll be writing every column as operator. Here in first consider this first expression in first part of the 3 address code, in which operator is u minus. So here in the quadruple representation we are writing u minus and argument as c, and argument 2 as we are not using any second argument, so we are leaving that blank, and finally we are storing the result into t1 as usual. In this way the quadruple representation of the expression is done. Here index is given as from 0. In quadruple representation we are considering the index of the every step as from 0. Okay, and coming to the triples, this representation doesn't make use of extra temporary variables to represent a single operation. Instead, when a reference to another triple's value is needed, a pointer to that triple is used. So it consists of only 3 fields, namely operator, argument 1, argument 2. Here op is the argument. And coming to the disadvantages of the triples, temporaries are implicit and difficult to rearrange the code. Here rearrangement of the code will become difficult. It is difficult to optimize because the optimization involves moving intermediate code. So when a triple is moved, any other triple referring to it must be updated also. With help of the pointer one can directly access symbol table entry. Let's look into the example of the triples representation of the three address code. Here three address code of the any expression will be same, but the representation differs in these three different ways, and I'm considering the same example, and the three address code will also be the same for that. And here uh, in triple representation we will be having only three different elements: operator, argument 1, argument 2. Here argument 1 is the operator 1, that uh, operand 1, sorry, operand 1 here, where the we are we the operator used in the three address code will be representing this. The operand, next operand in the three used in three address code will be represented. For the three address code, uh, for the three address code, let's first one is, here we are not storing any value to any temporary variables. So here u minus of c will be the first step of three address code, and then here u minus of c result will be stored in uh, first column of the triples representation, that means 0. So here in operator we will be representing star, and in operator 1 will be writing 0, means that column 0. Here you can use a number which is in which column the result is stored, and operator 2 is 0. Here in triples representation we have to read it as first column result star b is the is stored in finally second column. Here second column means index 1. Let's read it once again. And the first column result is multiplied with b and finally stored into second column. 0 star b is equals to 1. So in this way finally the result will be the whole result, that is a is a is assigned to the whole column result. Here from column 4 will be getting the result of the right side of the expression, which is stored in a. Coming to the indirect triples, in this representation it make use of pointers to listing of all references to computation which is made separately and stored. It's similar in utility as compared to quadruple but in quadruple representation and in indirect representation, in indirect triples representation it requires less space than quadruple representation. Temporaries are implicit and easier to rearrange the code. Consider the same example for the indirect triple representation, and this is the indirect triple representation for the code. So here operator 1, here there will be only a list of pointers to the table, and operator argument 1, argument 2 are the three different elements required for the indirect triple representation. Here 0 is considered as 14, and like 0 is pointing to 14. Here we can, in list of pointers 0 is pointing to 14, and 1 to 15, 2 to 16. We can take any numbers which are not there in the pointer numbers, which should point to a new number to store the result, and after storing the results we will be using this in arguments. After that we'll be storing this in arguments. So it is same as a quadruple representation. uh, U minus of C will be the first part of the three address code, and then uh, here 0 is pointing to 14. So 14 star B is a second part of the three address code, which is represented as like 14 is represent as argument 1, which is the operand, and 14 is multiplied with B and finally stored into 15, which is pointing to 1. Here we're not representing it as it is, but we are modifying it into uh, we we are modifying it into uh, new numbers which are pointing to the previous ones, not to mention the same numbers and same into the arguments. So these are the three different representations of quadruple representation. uh, Three representations of three address codes, and quadruple representation, triple representation, indirect triple representations are three different types. And uh, thank you.